Hello and welcome to the second video in this series where we are going to work through all of the Leetcode questions that are asked on interviews, and you will be able to solve the top 150. Today we're going to be focusing on the remove element question in the array and string section. This is also a difficulty rating of easy, so without further ado, let's get right into it. So whenever you open up the remove element here, the first thing that I always like to do is make sure that my coding language is set to Python 3. We have that set. And now let's go ahead and take a look at the problem here and we'll see what we're getting ourselves into. So the question here says, given an integer array, nums, and an integer value, val, remove all occurrences of val in nums in place. Okay, so in place here, essentially all this means is that we're just going to use the array that's given to us. We're not going to create something new. With that, the order of the elements may be changed, and then return the number of elements in nums which are not equal to val. So that's not too big of an issue, should be pretty straightforward. In the middle here we have consider the number of elements in nums which are not equal to val be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the element which are not equal to val, and the remaining elements of nums are not important, as well as the size of nums. Return k. So this is a little bit confusing right off the bat. I think the best way that we can kind of start to solve this is to actually look at an example. So let's go ahead and look at this example 1 down here so we can see what we're going to be working with. So in the first example here, we see that we are given an integer array nums, and it has these 4 elements. So it's given 3, 2, 2, and 3. We're going to be removing the value 3 from this array. So we should end with two elements that are both equal to 2. You can also see in the second example the same thing. But now that we have this, we can actually start working because it seems pretty straightforward. We're trying to remove an element, and in Python, there is a function that's already built in for removing that element. So let's go ahead and start typing this up. We are given the integer array nums, and we're trying to remove an element from this. So Python has a remove element function, and the element we're trying to remove is value. So given this, we can run this, and that's all there is to it. That's the end of the video. No, I'm just kidding. Okay, so this problem is not quite so simple. We, for the most part, have it actually how we want it to be. And then at the end, we're supposed to return the length of nums as k. So if we were to do this, we can see that we're not going to get the right answer because we're missing this last element that we didn't remove. We actually need to do a loop to make sure that we look for every occurrence, not just the first occurrence. To do that, we will say while val in nums, so we can go through every element. We will remove the val from nums using this while loop, and then we will return the length of nums. So if we were to run this, we can see that our result is accepted. And I can actually submit this as well. And very simply, very quickly, we can have an answer that beats 100%. Now, there is a way that this can be made faster. So this has a time and space complexity that is decent, The time complexity is equal to big O of n if there's only one element to be replaced. We only remove the element one time. But we have to do this for every occurrence of n, so this would actually be O of n squared. The space complexity is always going to be the same for this problem because it is an in-place problem, so we will always have constant space. So really the only area we can improve is time complexity. Now if we are wanting to improve upon this, especially in the time complexity area, the best thing that we can do is to actually write this out in a way that uses pointers. Okay, so now for the pointers example. So in this example, we're going to be trying to find a time complexity that's a little bit quicker. So the first way that we're going to do that is by not using remove, and we're going to actually use the pointer, and we're going to set the pointer equal to k for the start here. We're using k as the pointer because we're trying to return k at the end, and k will be our reference to how many elements are in our list of nums. So now that we have that created, let's go ahead and create a loop so that we can see how many elements are in nums. So currently for I in nums, if we were to print this, we would see all of the values that are in this. So I can go ahead and do that really fast here. We will see in the output all of the values that are in nums. So every time we're going to print nums, right? If we were to print I, we would actually get the specific value for the number. So we can see here that we're getting 3, 2, 2, and 3. But we don't want that. So we'll do the length of nums. And we won't just do the length because the length will give us an error. We will actually do the range of the length. So this will give us the length of nums, which is equal to 4. And we're going to find the range of 4, which will be 0, 1, 2, and 3. Those will be our indexes that we'll want. And we can print this out to see right here. We are given standard output is 0, 1, 2, and 3. So that's doing exactly what we want to happen. So now that we have our indexes, we can go ahead and see if that index is equal to the value. So to do this, we will create an if statement. We will say if num's index is equal to the value, we're going to remove the element, right? Before we would have done nums.remove I, but if we're going to do this, we'll get the same time complexity as above, just in a more complicated way. So why don't we do this in the inverse way? We're going to say if it's not equal to the value, then we will assign nums k to be nums I. So let's explain this really fast. So currently, k and I are both equal to 0 on the first time we run through this. 3 is equal to the value of 3. So k will not change, but I will go to the next element of 1. So now when we go to the index of 1, we're going to see that 2 is not equal to 3, and k, 0, is going to be overwritten. So we're going to overwrite this nums k, the 3 value, with the 2. The next time we'll pull the 2 and overwrite this 2 with a 2, and then the 3 we won't do anything. So in the end, we're going to have 2, 2, 2, and 3. We don't care about the last 2 elements in this list, however. We just want to return the length. So to do that, we're going to return k. And every time we go through this, we're going to increase k by 1. So when we return k in the end, we will end up with the final answer exactly what we were expecting to see. Sorry, put an extra colon here. Let me go ahead and remove that. Here is the actual final answer we were expecting to see. And there we go. Our test case is accepted, and we can run this and go ahead and submit. We beat 100% with the fastest time complexity. So what actually would this time complexity be when we look at big O of n time complexity? Well, the O of n is actually O of n for our time complexity. So we're not removing the elements this time. We're just going to look at each element in the list, and we're just going to go through and read each element one time. So if we go back to the description and look at our example, we're going to read through each element one time. So that will only be n times. And space, like I said above, is always going to be the same for in place. Since we're not creating anything new, everything will be constant, and that will be our constant time. So this is all that I had for today. Hopefully it was a little bit shorter, a little bit sweeter, and I appreciate everybody for coming by and listening. If you have any feedback or any ways that you think I can improve, I greatly appreciate that feedback. So please leave it in the comments down below, and I'll be happy to take a look at that. Thank you again.